Good morning, kids. Happy snow day. This would have been Friday's lesson, but we're going to have our test tomorrow. So this lesson will be what we would have done Friday, and the homework that accompanies this I'll check on Monday. So I'll have a bunch of stuff to check on Monday. Integration 1, Integration 2, Integration 3, and the derivative practice. Sorry, I know that seems like a lot, but it really is. This unit is very formula driven and very repetitive, so the more practice you can get, the better. Alright, so this would be the warm-up. You don't have to worry, obviously, about putting this in your warm-up book. And again, the homework is going to be integration number 3, which you need to find, print out on the Canvas site. So again, differentiating is crucial to be able to anti-differentiate. So remember, if I give you this function and I ask you to differentiate with respect to x, you have the inside function. This function is inside cubing, right? So you actually have to you're actually differentiating cubing, right? And think of this as x cubed, really. And to differentiate x cubed, you bring down the 3, you copy over the x, and you subtract 1 from the exponent, and then you spit out the derivative of the inside. And we usually don't write this part. We don't touch the inside, then we multiply by the derivative of the inside. So when we're done, it looks like 3 I started to differentiate that, didn't I? Times 6x, and then of course we generally combine this, right? We generally combine the products 6x and 3, and we get 18x. I mean, in reality, we could squaring 3x squared plus 7 isn't that big of a deal, and we could combine it even further. The challenge for anti-differentiation is taking this function and recognizing that it used to be a power of 3, right? That's not too hard. Power up. Remember the power up? Divide by the power up, right? So you would have to divide this by 3. There's your 6x, right? So you have to realize that this would be the derivative of the inside. If you're anti-differentiating, the derivative of the inside, this 6x has to show up somewhere in the integram, because remember, what I'm going to try to do, what I'm going to ask you to do, is anti-differentiate this. If I say anti-differentiate, you need to look at the integrand, say it was a derivative of something. Sure, I can recognize the power up, but if the derivative of the inside isn't part of your integrand, you're stuck. In general then, any function to the n power, if I take its derivative, is n, right? Bring the n down, don't touch the middle, subtract 1 from the exponent, and multiply by the derivative of the inside function, which is u. Again, our challenge is going to be when I ask you to anti-differentiate. Can you see the derivative of the inside in the integrand? So remember, 6x is spit out, du is spit out. When you anti-differentiate, you've got to, that's right, suck it back in. See that slurping? That's my slurping straw sound. If you have your sound turned on, you should hear it. Do I have my sound turned on? Oh, rats. Where's my sound? Oh well. Hopefully you can play your sound. It took me a long time to find the suck it up sound. So you hear it all throughout this. Hi, Dylan. So, u substitution, we call the inside function u. U substitution for the suck it up process is how we undo, see the u here? Undo the chain rule, which was spitting out. How do you undo spitting? You suck it up. Oh, there it is. So here's my recipe, and this is just mine, so for those of you who are watching this that I'm not your teacher, this is going to sound very weird to you. But find the inside function. I name the inside function u. And this is not just me. I mean, this is an actual thing, u substitution. That's not a gets thing. So use u for whatever you can find to be the composition, right? When I say inside, what you're thinking is the function that has been composed. Then you need to differentiate. This is why I'm giving you derivatives to practice. You need to differentiate that inside function so you can see the derivative. Really, you need to look for it. This is the challenge part. I'll show you why when I do examples. Once you differentiate, remember you're doing du dx, multiply by dx to get du by itself. Then get x stuff by itself. And I do have question marks here on purpose because this step is necessary sometimes and other times it's not. And again, I'll try to show you examples of both. Then you're going to substitute. It is, after all, called u substitution. And you're going to replace all the x and dx stuff with u and du stuff. Sometimes you've got a dilation factor that you need to osmosis out of the integral. Then you're going to integrate the outside. And what I mean by that is the u function. What you now have is the u function. Integrate it. Don't forget to write plus c if it's indefinite. Oh, I can't spell. And then you've got to, since you started in x, you've got to put the x stuff back. Always, if it's an indefinite, oh, I cannot spell. Indefinite, you always have to put the x stuff back plus this c, right? If it's a definite integral, your choice. And again, I'll show you examples of this. So here's example 1. This is the simplest u substitution example, because if you, the reason why is because I don't need my algorithm. I can, not just because of my age, not because of brilliance. I've done so many of these. I don't need to write anything out for this. I can see that the inside function x to the fourth minus 1 was composed inside of x squared, and further, the derivative of the inside is right there. So the derivative of x fourth minus 1 was 4x cubed dx. So since the derivative was right there, this is what is going to get sucked up. This is going to disappear. It's going to suck back up. It's going to get squished back in here because remember, it was doing the derivative, it got spit out, and then I'm going to add 1 to this power, right? I'm going to power up. But let's pretend I don't have that experience. Let's pretend we are just going to follow the algorithm. So the algorithm says find, which you do have to do, right? You have to do this. Get it? You, ha ha ha. You have to find the inside function. So what you're looking for again is a composition. So hopefully you recognize x to the fourth minus 1 is my inside function. The squaring is what is my outside function. And what I mean by outside, it's what has been x squared has had x to the fourth minus 1 shoved into it. So I name my inside function u. Then I differentiate. The derivative of u with respect to x is 4x cubed. Then I get du by itself. Now, I'm going to do this problem here. Hopefully you see that right now I can directly substitute. I've got my u, so I can copy this integral down. Integral x to the fourth minus 1 is u. And this part is du, right? Du is the same as 4x cubed dx. So, u du. Oops, what did I forget? U was raised to the second power. Now I just go to my list of rules that we made yesterday, and we're going to use the power up rule on that. How do you integrate something squared? It's something to the third over 3, and since this is an indefinite for general antiderivative, I have to add c. So I identified u, I differentiated u, I got du by itself. I skipped this step because du was directly inside the integrand. I did not need to osmosis anything. I integrated the square by using the power up rule, divide by the power up. I added plus c because it was indefinite, and the only thing I haven't done is resubstitute. So my final answer can't be u because I started with an x. So I need to take this u and put back the x stuff. So x to the fourth minus 1 cubed over 3, or multiplied by a third, plus c. That's my final answer. Now I'm going to redo this same problem, but I'm going to do it a different way, so I better get the same answer, but I'm going to use this step and this step. So I got the du stuff by itself. Now I got the x stuff by itself. Do you see what I mean? The x cubed dx was multiplied by a 4. So I got the x stuff completely by itself, which means I have 1/4 du. X squared dx, I'm sorry, x cubed dx is not right there, right? So in order to get the integral of u squared du, I replaced x cubed dx, I replaced this part with 1/4 du. So do you see what happened to the 4 and the 1/4? And that's how I was left with just du. I still did not need to do any osmosis because the 4 and the 1/4 cancel each other out. And the reason I wanted to show you this way is because it is more likely that you're going to need to get the x stuff by itself. It is more likely that this dilation factor doesn't match up so nicely. So just finishing this problem, showing that I put the x stuff back. What? Oh, sometimes this can get confusing. Did you hear that? That was like a what? Alright, let's do another example of the suck it up. So this is a general antiderivative, right? There's no limits of integration. Since there's no limits of integration, say to yourself, well, I shouldn't put x's, I should put no limits of integration, therefore I'm going to make a note to myself to put a plus c at the end. I don't like the problem written this way. It helps me see the composition if I use powers. And then I'm going to change my ink color for anything outside of the composition. So this expression is inside the power of 1/2. So I'm going to call this u. I'm going to differentiate with respect to x. I'm going to get du by itself by multiplying both sides by dx. Then I check, do I need to get rid of this 2? Do I need the x stuff by itself? And hopefully you can see that in this example I don't need to do that. 2x dx is all right there. 1 plus x squared is all right here. Everything is covered up except for the 1/2. So now I can rewrite this write the red integral, write the parentheses, write the 1/2. But the yellow 1 plus x squared is called u, and the yellow 2x dx is called du. Now integrate with respect to u, power up, u to the 1/2 plus 1 is 3/2. Divide by 3/2, no, I will multiply by 2/3, and I will add c. I'm not done because I can't leave my final answer in terms of u. So there you go. So again, that's really all I can do now is make things messier for you. So notice what I've done here is instead of making an indefinite integral, I've made it a definite one. So we're going to use f of 1 minus f of 0. And I'm going to get a number out of this. Whereas when I have an indefinite, right, I get an algebraic expression. Plus c. So this is going to have the exact same work. I'm going to end up down here, so I'm going to skip all of this stuff and just write 2/3 u to the 3/2 plus c. I'm also going to write, oh, that was silly, I didn't need plus c, did I? I'm also going to write 2/3 1 plus x squared to the 3/2, and now instead of writing the plus c, I will write what I'm going to plug in. So let's do this replacing x with 1 and 0. I think I'll keep the 2/3 to the outside, and I'm going to write 1 plus 1 squared to the 3/2 minus 1 plus 0 squared to the 3/2. So this is 2/3. 2 to the 3/2 is what? The square root of 2 cubed? Well, that's not nice, so I'm just going to put 2 to the 3/2 minus 1 to any power is just 1, right? And if you want to get your calculator out and get that approximation, that's fine. I'm just going to leave it like that for now because I want to show you that it is not always, remember I said in that previous slide, it's not always necessary to use x when you have a definite integral. If you want to just leave this u, you can do that. And remember, I don't need the plus c. I'm going to evaluate this at two numbers, but these two are x numbers. And I can't put 1 and 0 here, I have to put u numbers here. Well, gee, how in the world, if I have an x is 1, how can I possibly turn that into a u number? I wish I had an equation that took a u, took an x and turned it into a u. Well, there you go. See what you want, make it happen. So when x is 1, what is u? Yep. 1 squared is 1, 1 plus 1 is 2. And when x is 0, what is u? Yep, 1. So now I can just use 2/3, 2 to the 3/2, minus 1. And you get the same result. AP, the reason I show you this for two reasons. One, oftentimes this is algebraically simpler to use, but the price to pay is that you have to remember to change your limits of integration from x numbers to u numbers. The other reason I show it to you is because AP likes this. They're going to force you into this situation. You're not going to see it coming, and they're going to force you into having to change your limits of integration to u numbers. So make sure you practice that. You know, when I give you the handout, some of the problems that you're doing that are definite integrals, some of them put back in x and evaluate. Some of them change to u and evaluate. Here we go. Alright, this one's a little bit of a dagger. See if you can see why. If you want to pause and see if you can do this yourself before then watching me, go ahead. Again, I like to rewrite this so that I see the composition. I highlight my inside function and I box the outside. I take my inside function and I call it u. I differentiate my inside function with respect to x, and I'm just going to skip the step. This is du dx, but then I'm going to multiply by dx. Now, here's where we have, for the first time, our dx part that I need to get rid of, I need to substitute dx, is just right there. It's got a 4 with it. Gee, if I want dx to be by itself and it's being multiplied by 4, what can I do? This is where you have to get the x part by itself. So now I have just dx. Now I can go and substitute. So I'm going to copy down the integral sign. I'm going to copy down the parentheses. I'm going to copy down what's in my box. And then I'm going to substitute. 4x minus 1 is now u. Check. Dx is 1/4 du. What? I don't want the 1/4 there. 1/4 is in my way. What can you do with it? It's a multiplier. What can you do with a multiplier? It's not an argument. It's not being added or subtracted. It's a multiplier. That's right. Osmosis. Suck that 1/4 out here. This was an indefinite integral. There were no limits of integration, therefore plus c. I have to put x back. How do you anti-differentiate u to the 1/4? That's u to the add 1. I'm sorry, u to the 1/2. Add 1, and you get 3/2 divided by 3/2, so that's 2/3 plus c. Now what did I forget? And I did that on purpose because a lot of kids, once they osmosis the 1/4, they forget about it. Don't forget you also have a 1/4 here. So this is actually 2/12, or of course, silly me, 1/6 u to the 3/2 plus c. Now hopefully some of you are asking the question of, hey, doesn't that 1/4 have to multiply to c? Yes, it does. But 1/4 times a constant is still what? Just a constant. So now let's put our x stuff back. And there you go. So this time I had to do some manipulation around du. The whole point to u substitution is that you have to completely, once you choose u, you have to completely use up everything everything else. The dx and everything else that's outside the 1/2, you have to be able to highlight, to get rid of. Alright, so for the first time, now all of my other examples have used the power up rule. This time, who is inside? That's right. 3x minus 1 is inside, but it's not inside of power, it's inside of cosine. So I'm actually going to be anti-differentiating cosine. So I'm going to call 3x minus 1 is my u. Differentiate u with respect to x, and then multiply by dx. So I have another issue where my inside is covered up, but I only have dx to get to cover up, but yet my du is 3dx. Since I only want dx, I need to get rid of that 3. Once I get rid of the 3, I highlight the dx. Now I can cover up the dx and I can substitute. Copy over the integral. Copy over what you're actually integrating. Copy over the parentheses, but instead of 3x minus 1, you're going to put u. And instead of dx, you're going to put 1/3 du. I'm going to put my du here, and what am I going to do with that 1/3? This is an indefinite integral, so I'm going to add c at the end. I must put the x stuff back after I anti-differentiate. So what is the antiderivative of cosine? And why don't I just resubstitute right now? So instead of u, I'm going to put now, of course, again, how can you check any of these answers? Any answer at all. How can you check it? Differentiate. So what if I had to differentiate 1/3 sine 3x minus 1 plus c? If I was taking the derivative, it would be 1/3. The derivative of sine is cosine. Copy over the middle. Spit out the derivative of the inside. And the derivative of a constant is 0. And then, of course, what happens to these 3's? And I get cosine 3x minus 1, which is what I was anti-differentiating. Yay! Whoa! Holy cow. What the heck is going on? I've got powers, I've got trig. So, sometimes when you're anti-differentiating, it's not immediately obvious what you're doing. This is an indefinite integral, so I'm going to be adding plus c. So I say to myself, firstly, I wonder if, right, I've got something to the 5th and something squared. I also have a multiplier. I wonder if I should osmosis that out, and right, from the very beginning. So I say to myself, should you, maybe I think, should you be secant 3x? Question. Since I have a bunch of stuff happening, should I have u be secant 3x? Right? Because secant 3x is being squared. So maybe that's my inside. So I say, is this u? And I check. Well, what is the derivative of secant 3x? Let's see. The derivative of secant is secant tangent. So secant 3x tangent 3x times 3. And then, of course, dx. So my question is, do I see all of that in there? Oh, there's tangent of 3x. Oh, crap. Tangent of 3x is to the 5th. I have tangent of 3x, but I don't have an extra. I do have the 3, but I don't have an extra 3x. Plus, I've got 4 more tangent 3x's. Ugh! That's not going to work. Start over. Choose a different u. So what else? If secant 3x didn't work out, who else do I have? I have tangent of 3x that is inside a 5th. So if this time I choose tangent 3x to be the inside, I don't know if this is going to work. It's inside a 5th, so I would be anti-differentiating something to the 5th, which would be something to the 6th over 6. I don't know if this is going to work, but I know when I chose secant 3x to the 2nd power and tried to anti-differentiate that, it didn't work because the derivative was not here. That never happened when you were differentiating. Somebody gives you something to differentiate, you just go with it. And maybe you have to look up a formula, maybe whatever. But there's never a blocker, right? This time, when you're anti-differentiating, there is a big blocker. There's a big obstacle. If you do not see the derivative of the inside function, you can't go on. So I chose secant 3x. Its derivative was 3 secant 3x tangent 3x, and the whole derivative was not there. I had to stop and start over. So now I hope this works. If u is tangent 3x, the derivative of tangent is, shocker, secant squared. Don't forget the chain rule. Secant squared 3x times what? 3. Now, go highlight and see if you can cover everything up. There's u. What do I need to replace du? dx, secant squared 3x, and a 3. Is everything covered up except for what you're integrating? This works. Once I've done that, I can now copy over the integral, copy over what I'm integrating, call it u to the 5th, and then remember 3 secant squared 3x and dx all are represented by du. How do I integrate stuff to the 5th? Plus c, because there was no limits of integration. I have to take my u stuff and replace it. There we go. Done. Check. Of course, how could you actually check? Take the derivative. What is the derivative of tangent 3x? Secant squared 3x times 3 plus 0. Whoops. Stupid. There, that works. What is the derivative of tangent 3x to the 6th? Bring the 6 down. Tangent 3x to the 5th times secant squared of 3x times 3. There we go. Whoa, dear. This looks horrendous. Notice that the last problem was a product. Integrating a product is very difficult unless everything matches up with u substitution or matches up with a formula from your formula sheet. Same with a quotient. Integrating a quotient is a big hairy mess unless I can figure out a way to do u substitution. So let's check this out. Firstly, no limits of integration, so I'm going to have to plus c this. Alright, firstly I want a power, so I'm going to write 2x plus 1, and then I'm actually going to write this as x squared plus x plus 3, not to the 1/3 power, but to the what? Negative 1/3 power. That helps me see the composition a little bit easier. So I see this parabola has been shoved in to negative 1/3. What's its derivative? Oh, wait a second. This isn't nearly the dagger I thought it was going to be. Right? Everything worked out beautifully. It looked like it was going to be such a mess. Look. U is completely covered up. Du is 2x plus 1 times dx. Everything is covered up by u and du except the negative 1/3, which is what I'm going to anti-differentiate. So copy over the integrand, copy over what you're actually going to integrate, replace x squared plus x plus 3 with u, replace 2x plus 1 dx with du, and integrate. How do you integrate stuff to the negative 1/3? That's stuff to the 2/3 divided by 2/3, which is actually multiplied by 3/2, plus c. Put your x stuff back. And differentiate if you doubt it. bring down the 2/3, copy over the middle, subtract 1, spit out the derivative. Now, what if we did that problem as a definite integral? So same problem, but I gave you limits of integration. Remember, since these are x functions and you're anti-differentiating with respect to x, these are x numbers. So you've got two formulas that you can use with a definite integral. You can use this one, or you can use this one. It doesn't matter, but I suggest that it might be worth your time to change your x values to use and just plug them right in here. So let's try that. Whoops, I don't want. So, remember my u was x squared plus x plus 3. So what is u of plug in 3 and plug in 1? I want to take this x and turn it into a u. So plug it in. So 3 squared plus 3 plus another 3. 3 squared is usually 9. 9, 10, 11, 12, 13, 14, 15. And 1 squared is usually 1, plus 1 is 2, plus 3 is 5. So, take 15 and 5 here. I don't need the plus c, so I'm just going to say 3 halves times 15 to the 2/3 minus 5 to the 2/3. And I will leave that answer like that, since those aren't integers. Okay. If you have a calculator, you can math 9 that and check it. Alright, so integration 3, again, that handout is on our site. If you will download that and do those problems in addition to the integration 1 and 2 worksheets. Remember, all of this, the only thing that's going to be due tomorrow is your little book. So on Monday I will check integration 1, 2, 3, and then your derivative practice. So you have some snow days time today, and then the weekend to work on these. Have a great rest of your snow day.